So today we will go over a concept called the GCD and LCM. So before we look at the concept and some relationships between these two ideas, we will look at what each of these stand for. So first for GCD, let's write this down. GCD stands for the greatest common divisor. So GCD stands for greatest common divisor. Unlike how it sounds like, it basically means the greatest common factor between two or more numbers. Oops. Yeah. And so let's say we want to find the greatest common divisor between two integers a and b. Then we can write it as GCD of a and b. So this is the notation for GCD. Or we can also write it as, we can just write a and b in brackets, but this notation is rarely used, and we normally use this notation. Yeah. So for example, if we take out an example, let's say we want to find the GCD of, let's say, 48 and 36. And I don't want to do this right now, but if you can, to find the GCD of 48 and 36, we can list out all the factors of 48 and all the factors of 36 and find the number that is the largest number that is both a factor of 48 and 36. And it turns out to be 12. So that's how you find the GCD, but it's not a very efficient way, because when it comes to larger numbers, you don't want to list out all the factors that it has. So a quicker way would be to prime factorize it. So if we prime factorize 48, it is equal to 2 to the 4 times 3 to the times 3, and 36 is equal to 2 squared times 3 squared. Okay, that 3 looks a bit ugly. 3 squared. And how we do this is basically the greatest common, if we want to find the greatest common divisor between 48 and 36, then that number must have a number of 2's and 3's in itself that both go into 48 and 36. So basically, we have a 2 to the 4 in 48 and a 2 to the 2 in 36. So the greatest common divisor must have 2 2's. If it has 3 2's, then it won't divide this number. So it will have to have 2 2's in order to divide both numbers. So let's circle this. And for the 3's, similarly, we want the greatest common divisor to divide both numbers. So, and we want it to be the largest number. So there's 1 3 here and 2 3's here. So we want to have 1 3. So the minimum between these two, because we want the number of 3's in the GCD number to go into both of these numbers. So in conclusion, we get that the GCD of 48 and 36 is equal to, I'll just write just GCD because I'll just violate some notation. This will just be equal to 2 squared times 3, which is equal to 12. So yeah, this is a much quicker method than listing all of the factors. So yeah, that's a tactic for finding the GCD. And now next, we'll look at the LCM. So let's write this down again. So the LCM stands for the lowest common multiple. So basically it's like the opposite concept of the GCD, so the greatest common divisor. So let me get my pen back out. Here we go. And this time for lowest common multiple, usually people write LCM if you want to find the lowest common. So what this means is basically the lowest number that is both a multiple of two or more numbers. So for example, if we want to find the lowest common multiple of two numbers a and b, then we denote it as LCM square brackets a and b. Or we can also just write this, but this notation again isn't used that often. But again, just to remind you, these aren't notations that everyone uses. So Yeah, it's just a recommended notation that most people understand, most people use, but it's not like um, a notation that all mathematicians and students use. But anyway, it's good to know. So, for example, to find the LCM, we can have, oops, not that color. For examples, we need pink. So LCM, let's say we want to find the LCM of 4 and 6. And again, what we do for this is we list the multiples in increasing order for 4 and 6. And we keep listing it until we find the lowest number that is both a multiple of 4 and 6. And so if we keep listing the multiples, we won't have to go far for these two numbers because they're pretty small, and their lowest common multiple turned out to be very small too. Will be 12. Yeah. And again, like this, we don't want to list out all the multiples until we find a number that is both a multiple of all the numbers. So again, we can quickly find the LCM using prime factorization. So again, let's factorize 4, which is just 2 squared, and 6 is equal to 2 times 3. So this time, here we found the minimum of the exponents because the GCD has to go into both of these numbers. But this time, the LCM has to, let's say, I don't know how to express it, but like cover all of the numbers. So we want to find the maximum exponent because these two numbers must both divide the number. So instead of finding the minimum exponent, this time we find the largest exponent of each prime factor. So here we have two 2's and one 2 here, so we're going to take the two 2's here. And here we have no 3's, but we have a 3 here, so we'll take the 3 here as it is larger. So we're finding the lowest number that is the parent. I don't know how to express this, yeah. That is the multiple of both 4 and 6. So we found the largest exponent, which gives us that the LCM, therefore, is equal to 2 squared times 3, which is equal to 12, as we found before. Yeah, so GCD and LCM, they're two different concepts. They're opposite, but they require very similar techniques and similar conceptual techniques, I think. Yeah. So, yeah, that's how you find the GCD and the LCM. And I think I'll give you some examples so that you can get your mind around this. So try finding the GCD of 96 and 144, and try finding the LCM of, let's say, 27 and 39. So I recommend you to pause the video and have a go at these examples before we end the video. And so the answers are, so for this, first we prime factorize 96 and 144, and if we do that, we get 2 to the 5 times 3, and 144 equals 2 to the 4, 2 to the, what's like this? Okay. 2 to the 4 times 3 squared. And so for the GCD, we want to find the minimum exponent for each of the prime factors. So here the minimum exponent between 2 to the 5 and 2 to the 4 would be 2 to the 4, and between these two it would be 3. So the greatest common divisor, GCD, is basically just equal to 2 to the 4 times 3, which is equal to 48. That's a pretty large GCD. So yeah, good job if you got it right. And for the next question, for the second question, again we just prime factorize it. So normally if you get a GCD or LCM question, normally you will have to prime factorize all the numbers involved in it, and because it will greatly help, as you can see here. So 27 is equal to 3 cubed, 39 is equal to 3 times 13. So again, this time for the LCM, we want to find the maximum exponent. So the maximum exponent for 3 would be just 3 cubes here. And the maximum exponent, there's no 13s here, but there's a 13 here. So we get just 13 for the largest exponent for 13. So the LCM is equal to 3 cubed times 13, which is equal to 351. Yeah, so good job, you got those right. And if you still don't understand, maybe if you still find it a bit difficult, maybe try finding the GCDs and LCMs of some numbers and you'll get the hang of it somehow. Yeah. So, yeah, just to recap, so for GCD, to find the GCD, you prime factorize both numbers and find the minimum exponent of each prime factor in both numbers. And for the LCM, you do the same thing, but instead of finding the maximum exponent. Yeah, so it'll be kind of confusing to remember because this is greatest common divisor, but you find the minimum exponent, and then vice versa for this. But yeah, if you with some practice, it will come to your mind quickly. So yeah, in the next video, we'll go over a very important relationship between the GCD and LCM, which would be helpful in a lot of AMC problems. And also in the AMC playlist section, there will be some AMC problems about GCDs and LCMs too. So hope to see you guys in those videos too. And yeah, hope you enjoyed the video and see you next time.